So that brings up a good point. Part 3. That brings up a good point. Alex asked me, can these two things cancel? And my answer is no, they cannot cancel because of this subtraction sign. Because of this piece here is in a relationship with this, we would be breaking order of operations. We cannot, this line right here basically makes this whole numerator being divided by this denominator, and you would only be dividing this thing and not both things by that thing if you cancel out one of these two things. So do not do that. Okay, when doesn't the quotient rule work? It doesn't work when there are complex fractions. So if there are complex fractions, you need to get rid of complex fractions before you start. For example, if I have something that looks like this, 3 minus 1 over x plus 5. Let me move that up a little bit.
Oh, God.
If I have 3 minus 1 over x all divided by x plus 5, this is where it gets a little bit hard, because as I do low d high, when I do the derivative of the high one, now I have a variable in the denominator. Now it goes back to the rules that we learned, or the limitations that we had in the previous section. You can't have a variable in the denominator using the power rule. So what do we have to do here first? The first thing that I would recommend we do is bring it up. You can either do this, or because it's a fraction, we could get rid of the fractions first. This answer here will give me, if I try to take the derivative of it right now, if I try to take the derivative of it right now, I'm going to have an extremely complicated answer to get rid of complex fractions. Your answers cannot contain complex fractions. Do you remember how earlier I told you your answers could not have any negative exponents, and your answers could not have any complex fractions? So even though I look at this problem right here, there's no complex fractions. If I try to solve this problem by doing what I just did, there's going to be a complex fraction, because what's the derivative of x to the negative 1? What's the derivative of this? So do you see how this piece here would end up making or creating a complex fraction inside the derivative? Well, so our recommendation is not to do this. Our recommendation is to get rid of the complex fractions before you take your derivative. So what I'm recommending is that we multiply the top and bottom by the common denominator. Technically, I'm multiplying by 1. I'm multiplying by x divided by x, which is 1. So this is still going to be equivalent to itself. The multiplicative identity is 1. So I'm going to multiply by that. And as I do, I get 3x minus 1 over x times, I would do x squared plus 5x. If I did not distribute this denominator, then I would have a product. And you don't want to have a quotient rule and a product rule inside a quotient rule. That would make it really hard. So always simplify beforehand, is to make sure you're doing these things correctly. So now we have our function, and I can use low d high minus high d low over the square of what's below. Low, in parentheses, d high. What's the derivative of the high one? 3. Minus high which is what? Maybe I'm going too fast. I'll slow down.
3x minus 1.
3x minus 1 minus high d low
2x plus 5.
X plus
over
X plus 5 squared.
Are there any complex fractions here?
There's no X.
No, sir.
Is it X? Oh wait, never mind.
There's no complex fractions, whereas if I try to solve it the way that I was showing you before, you would have had complex fractions that you would have to get rid of when you were simplifying your problem. So it's better to get rid of them in the beginning. Keep that in mind. Okay? There's two other major ideas that we have to do. The first idea is, what's the derivative of your other trig functions? Do you remember how I told you the derivative of sine? Do you know how I told you the derivative of cosine?
Yeah.
Well, what about the derivative of tangent? Of secant?
Oh, jeez. Jesus Christmas.
Of cotangent? And cosecant. When I was learning these, I literally had to make flashcards last year. I had them posted along the room. I had post-it notes around the room. So that every time I went to go turn off the lights, I would see, oh yeah, the derivative of secant x is secant x tangent x.
You're gonna get that trick though.
So let's write down what the derivatives are. The derivative of tangent x is secant squared of x. The derivative of secant of x is secant x times tangent x. Put a little line here so we don't get confused. The derivative of cotangent of x is negative cosecant squared of x. The derivative of negative cosecant of x times cotangent of x. The derivative of cosecant is negative cosecant x times cotangent of x. You could actually figure out what the derivatives were based off of the quotient rule and your knowledge of sine and cosine. So if I was trying to think of a very good problem for your chapter test, I might say something like this. Prove to me that the derivative of tangent of x is secant squared of x. And how I would expect you to do that is that you would show me, you know, tangent of x is sine over cosine. And then I would expect you to do low d high minus high d low over the square of what's below with the sine of x and cosine of x. And knowing how to do that, you could prove this. You could show me how it works if you understood everything I just said. Michael.
Do you mind showing us one of them, like cosecant x? The derivative of cosecant x.
What is the cosecant of x?
1 over sine of x.
1 over sine of x, right? So if I had, I'll start one for you because I don't want to cripple you, of course. 1 over sine of x.
What?
I can feel the crippleization.
Isn't that the same thing so far as 1 over or cosecant of x?
Yeah.
So then I would do something like this. Low, if I'm finding the derivative of this, low, what's the derivative of 1?
0, 1. No.
Of a constant. Derivative of a constant.
0.
Low d high minus high. What's the derivative of the low one? Derivative of sine is what? Cosine x over the square of what's below. So if I simplify this, guess what it simplifies to?
That.
This. So this is cosine over sine. This is 1 over sine and it's negative. That's what it's all going to come down to. Here's a cosine over a sine. Here's a negative 1 over a sine. That's where that comes from. That's where that comes from. Okay? So It's a simple way for you to figure out what the derivative is. Last concept.
Why did you cross it out?
Because this is what I want you to really focus in on. Do you know your derivatives? This is something you're going to have to commit to memory. You're going to have to know them. Lastly, we've talked about this before, but just in case. S of t is position. If I take the first derivative of position, the derivative represents what for position? Velocity. And if I take the derivative of the derivative, otherwise known as the second derivative, the derivative of the velocity, that would be?
Acceleration.
That's important. So you can have as many derivatives as you want to in the big scheme of things. Your textbook is going to write them like this. Like this is y prime is a first derivative. This would be a second derivative. This would be a third derivative. As a matter of fact, after the third derivative, they start going by numbers. Like they will put them in parentheses so that you don't get confused that it's a power. It's not a power. They're saying, I want the fourth derivative of y, but it'll be in parentheses so you don't get confused. It means I want the fourth derivative of whatever y's function is. Sometimes they will also write it like this. dy over dx. The first derivative of y with respect to x. If I'm looking for the second derivative, they would write that second derivative like this. D squared y over dx squared. And that means the second derivative. D squared y over dx squared. It basically means we're trying to find the second derivative. And it goes on from there. They always square the d on top and the x on bottom for whatever reason. There is a reason why I'm drawing a blank right now. I'll have to think about what I did before. So, if I ask you to find a second or a third derivative of something, it's really easy to do. If I gave you a function that was like negative 16t squared plus 16, and that's my position formula. My velocity function would be what? My acceleration formula would be negative 32. And acceleration generally will be feet per second squared. Velocity is in feet per second. This is in feet. That's in feet per second. That's for feet per second squared. Kind of interesting how that works. But that's basically how it works. You're taking the derivative of the derivative. Exactly. So that's where we're going to stop our notes.
Yeah.